So, hello everyone, and welcome to this weekly online session that we conduct, Ask AuxEn Anything. And as you all know, that this is an online platform for the civil structure engineers to interact with us and ask their difficulties or doubts or queries related to any project that they are doing, or RCC steel design concept, or construction and site issues. So this is the 31st such session that we are conducting, and let us begin and see what are the questions we have for this week. So I'll just share my screen. So I'll just share my screen and let us see the queries that have been asked. So first we will take up queries from the Google form, and then we will take up the queries from the email, and then from YouTube live comments. So this is the first question that has been asked by engineer Saurabh from Lucknow, and he is a postgraduate student. So he is asking if I assign my wall load uh, in dead load in the same load which has default multiplier 1 and separate pattern with superimposed dead load as pattern type, how does it affect my mass source and it will affect my structure? I'm not sure if what he wants to ask. If I assign my wall load, I think what he is asking is that suppose he has defined one pattern load named as dead load, and it has the self-weight multiplier assigned as 1, and now he's asking, he has defined another load pattern named as superimposed dead load, and here also, let's say if he assigns the self-weight multiplier as 1, then this will be an issue. This is an issue. Why it is an issue? Because what will happen now, that ETABs will duplicate the self-weight. So duplication of self-weight will happen. Self-weight means whatever items you have modeled in your ETABS model. So let's say if you have modeled the slabs, the beams, the columns, whatever you have modeled, those loads will be added two times if you have the self-weight multiplier 1 and 1 assigned to two different load patterns. So let's say now when you create this kind of a load combination, just an example. So what will happen, that when you create this type of a load combination, this dead load and this superimposed dead load both have self-weight multiplier assigned as 1. So there is a duplication of self-weights. So this should be avoided. This is not correct. So what is suggested is that you have all the other self-weight multipliers as 0. Only for one load pattern, call it, let's say, as dead load, you keep the self-weight multiplier as 1. And why even create all these different load patterns for superimposed dead load, wall loads? Why to even create separate load patterns? You can just have it in dead load itself. So just create one load pattern for all your dead loads and just put everything in that. I'll suggest that is the better way, rather than defining multiple load patterns where you are defining dead loads. Okay. All right. So next question is from Ajinkya Dinnapurkar, and he is joining us from Noida. He is a working professional, and what he is asking, are time dependent material properties and long term effects need to be incorporated in auto construction sequence case in ETABS? Yes, they need to be incorporated. Yes, because when you are doing I mean, see, if you are doing auto construction sequence and you are working for a long time period, let's say your building will take, and I'm talking more about the multi-story structures over here, high rises or tall buildings, 60, 70, 80 floors, then it takes 1 year, 2 year 2.5 years just to construct all these stories, isn't it? And for very tall buildings, or for tall buildings, you are interested in doing the construction stage analysis. So you should incorporate the long term effects of material also. That is what you should do. So yes, material properties should be incorporated. By default, ETABS does not capture this. Yeah, you are correct. By default, it does not capture the material time dependent material properties. By default, are not considered in ETABS. So you have to switch it on. The time dependent material properties, you have to switch that option on in the ETABS. As a default, it will not consider that for auto construction sequence. A peer reviewer is asking me to incorporate this in my high rise project. Correct. So you should incorporate. If incorporated, how does it affect the high rise structure? Need your thoughts. If possible, quickly show this in ETABS. So you need to refer to ACI. So there are different uh, for calculating the time dependent properties and time related material properties, and how it is going to affect your overall structure. There are different documents that you need to follow. So when you switch on in the ETABS, this time dependent material option, there are different documents according to which you can do this calculation. So ACI, there is this ACI 209R. This is one of the documents. Or there is this CEB FIP 90, I guess. This is one of the documents according to which you can calculate the time dependent material properties. There are a couple of other documents also. So according to these, there are various factors like uh, the temperature, like the cement content in your concrete, or the aggregate type in your concrete. So there are several factors that you have to consider when you take into account these time dependent material properties. And in ETABS, you have a ready made form available. So in that ready made form, you can just put in all these values, and then you will start getting the time dependent properties. It's not possible to show over here in ETABS because it's a long discussion. However, we have done this discussion in a lot of detail in our course on tall buildings. So we have conducted a course on RCC, tall building design and detailing. In that, we have covered this aspect in great detail, the time dependent properties as well as the construction stage analysis, how to do the time dependent material property calculation, all those things, how to calculate the axial deformation of vertical members. All those things we have covered in a lot of detail. If you are interested, you can have a look at this course. Otherwise, you can just go through these documents, ACI 209R 92 or CEB FIB 90. I think there is one CEB FIP sometime in 2010 also. So all those documents you can refer to. Okay. All right. Then the next question is from Mr. Anshuman Adhikari. He is joining us from Guwahati, and he is an independent consultant and a working professional. So what is his query? Please throw some light on different types of analysis in Idea Statica and which is used in which context. So there are different options available in Idea Statica, different analysis options. One is this, I think, EPS analysis option, which is the elastic plastic stress strain analysis. So this is your uh, default option. Normal analysis you can do through this option, EPS analysis. Then there is this stiffness analysis option in Idea Statica. How many of you use Idea Statica? How many of you use Idea Statica? No one uses. Okay. So Idea Statica is the software for connection design detailing, structural steel connection design detailing. So it's a good software, intuitive software, and it is better than this RAM connection software that is developed by Bentley. So it is much better than the RAM connection. So this Idea Statica is a component-based FEM analysis software. So if you are into structural steel design, it's a good software to learn and use for your uh, connections. So different type of analysis options in Idea Statica. So EPS is one. In ST analysis, you do the stiffness based analysis. So for stiffness classification, or to find out the rotation of your connection for the applied moment, you can use this ST analysis. Then one is this CD analysis in Idea Statica. In CD analysis, it will do the uh, capacity based design type of a thing, capacity design as per the ductile design detailing approach. So let's say AIC 341, or let's say in your Indian standard, you have the IS 18168. So it's a capacity design where you can define that these are the dissipative items, or these are the items which will undergo inelastic deformations, and accordingly, it does the analysis for your connection, analysis and checks for your connection. So this is that CD analysis. Then there is this D, if I remember correctly, DR analysis, where you do the uh, where you find out the capacity of your connection, where you can find out the capacity, how much or what is the moment capacity or what is the shear capacity of your connection, that you can find out in this DR analysis. Then I think there is this fatigue analysis, where you can do the cyclic testing or fatigue related checks. So this is fatigue analysis. And I think now in the newer versions, they have also included this analysis for fire. So for fire related options, they have included this type, analysis type, fire. So these are the different options available in Idea Statica for analysis. Okay. Okay. Then his next question is, when we design stiffeners for girder design, we mostly assume the C value. However, at times it may not be possible to provide the stiffeners at exact locations. What do we do then? So he is saying that in stiffeners, let's say he is designing a plate girder. I'm showing a plate girder in elevation, and he is saying, Mr. Amshwan is asking that you have provided stiffeners. So stiffeners are at a spacing C. So we have decided, or we assume a C value beforehand in the design. So typically for shear checks, we may have to do this. However, at times it may not be possible to provide the stiffeners at the exact locations, like presence of secondary members, presence of splicing, etc. What do we do then? See, you need to understand that this C value, if you are providing stiffeners, it's very rare to see that your girder. So even if you provide stiffeners at a large spacing, okay, that means even if you provide stiffeners at around 1.5 to 2D spacing, it's very rare to find that the stiffener or the plate girder is failing in shear. Generally your plate girder sections do not fail in shear. They will be more critical for bending moments, deflections, etc. So for shears, they are rarely critical. Now at shear also, for which at which location they will be critical. So for shear, they will be critical more at the supports, isn't it? So at supports, or at places where you have some secondary beam joining to them, at those locations, your shear may be more critical. So you need to keep this thing in mind, that at support locations or at locations where secondary beam is getting attached, you plan your stiffeners properly. Okay. So there you may have some load bearing stiffeners also. At secondary beam locations also, you may have to provide some load bearing stiffeners. At other locations, these intermediate transfer stiffeners, they may not be very critical, and if required, you can alter their spacings also. That's not a problem, because at intermediate locations usually shear will not be a big problem. So at the locations where shear is a big problem, like at supports or at connections with secondary beam, there you should be careful that proper stiffening arrangement is provided. In the intermediate location, you can check that even if there is some alteration uh, there is some alteration in the stiffener spacing, you can just check if it is passing or not. Usually it will pass. So just be careful at supports and at locations where point load is getting transferred. At other locations, you can alter the stiffener spacing. Just check if it passes finally or not. Okay. All right. So this was engineer Anshuman Adhikari. Then we have engineer Hassan from Darbhanga, and he is a working professional. And he is asking when to use eigenvector and Ritz vector. So I am not very sure about this answer. When to use eigenvectors or Ritz vector, but as far as I know, Ritz vector you can choose if you want to extract some specific model information. If you want to extract some specific model information, then you can use this Ritz vector analysis, and using this Ritz vector you may be able to get that specific model information. For example, if you wanted only those modes which are contributing, let's say, more than 10%, or which are contributing more than 15% of mass participation, and you run a Ritz analysis, so as per your specific requirement, it will only extract those modes. This is my understanding. I'm not saying it's correct or appropriate, but this is what I understand, that using Ritz vector, we can extract the specific model information, and we can restrict our analysis only to give us this specific model information. Using eigenvectors, it will do a general model calculations, and it will give you all modes. And for specific, you can run a Ritz vector. This is my understanding of the difference between the two. Okay. Then he is asking how to check the base shear contribution in columns and walls. So you can see when you have, this is your frame, and let's say these were your walls and these are your columns. This purple line is column, green line was wall, and let's say it is acted upon by some earthquake load. So the earthquake load will transfer in two manners. One will be the tension compression couple, okay, and the other will be the overturning moment. Not overturning moment, the moment. Let's say this is the moment that is created. All right. So if what you can say, okay, I have not drawn the active forces. Actually, I have drawn the reactive forces. Okay, it's all right. So what I can say, that the total, I can write two equations over here, that the total overturning moment shall be EQ into H. This will be equal to M1 plus M4 plus T1 into X1. Okay, is it clear? So moment of this couple, and I will say T1 is almost equal to C1, and let's say T2 is almost equal to C2, and I'm writing this plus M2 plus M3 plus T2 into X2. So this is how you can say that the total overturning moment will be resisted. Now out of this portion is getting resisted by the walls, yes or no? this portion is getting resisted by the walls. I am saying these were my walls and these were my columns. So this portion is getting resisted by the columns and this portion is getting resisted by the walls moment. So now overall you can find out that how much percentage of total moment is getting resisted by walls, how much portion of total moment is getting resisted by columns. Is it clear? Yes or no? So this is one way to find out the percentage sharing that is happening between the two elements. Now what is his next question? How to check base shear contribution? Yeah, no, so see base shear you don't see in that way. You see that, let's say this is my base shears being taken V1, V2, V3 and V4. So overall your EQ will be equal to V1 plus V4 plus V2 plus V3. So out of this base shear is resisted by walls. This base shear is getting resisted by columns. So what our code says that you have to consider or you have to find out the effects of earthquake and how they are resisted by the elements. That is what you need to find out. So when do we use the dual systems? So if your columns, it depends on the zone. It also depends on what amount of columns you can provide, what are the architectural requirements. So if you are not able to provide sufficient columns, maybe you will have to add some wall like elements, and then if it satisfies certain conditions, the sharing conditions, then you can have them as dual systems. Okay, so it all depends on the architectural planning and the structural framing that you are providing. So if you are able to provide all frame, column beam frame, then it will be more or less like a moment frame system. If you are not able to provide adequate frames and you have to provide walls, structural walls, RCC structural walls, but framing is not possible everywhere, so then you may have to think about a dual frame system where you have frames plus walls. So then there are certain conditions of the dual frame system. When can you call them as dual frame, etc., etc. So you can look into the IS 1893 and IS 13920 for further requirements. But to answer your question that how much wall is resisting, how much column is resisting, you can find out in this manner. Okay. All right. Then we move on to next question. Next question is from uh, engineer Abhijit Galatage. He is joining us from Pune. He is asking, working on pipe rack structure, facing problem. He is saying working on pipe rack structure, facing problem in performing non-linear second order analysis. I have no idea about performing non-linear second order analysis. I have no idea. I think you are trying to ask out the direct analysis approach. If you are asking about direct analysis, that I have good idea. If you are asking the direct analysis requirements for stability, about that I have good idea, but I'm not sure what do you mean by nonlinear second order analysis. So material nonlinearity, I have no idea. Material nonlinearity, I have no idea. If you are asking about geometric nonlinearity, it is more like a direct analysis requirement that is given in AISC 360 now, that the default method for analysis is the direct analysis as per the AISC 360 chapter C, designed for stability. And your StatPro and ETABS are able to do the direct analysis checks, where you have to consider the P capital delta and P small delta analysis, where you have to consider the stiffness modification. These are the requirements of direct analysis, where you also need to consider the tau b additional stiffness modifier, and where you also have to consider the notional loads. So these are some of the basic requirements of direct analysis, and these options are built in ideas. Sorry, these options are built in your ETABS and STAT both. So this I know, and we have discussed this thing in great detail in our course on steel design based on AISC codes. But material nonlinearity, I don't know. But I don't understand, if you are using a steel pipe rack, where does the question of material nonlinearity come into picture? I don't think material nonlinearity is so important for steel structures. I don't know why you are considering material nonlinearity. Anyway, so this was engineer Abhijit, and then we have next question is from engineer Hassan Intikhab. Intikhab, he is joining us from Darbhanga. He had asked the question related to the eigenvector and Ritz vector. He is asking, can you explain the axis system of frame and walls? No, what is the explanation you need? What is the explanation do you need? For walls, if I talk only about ETABS, generally this is the local axis 2 2, this is the local axis 1 1, and along the height of the wall is local axis 1 1. This is 3 3, this is 2 2. Okay, and let's say this is the length of your wall, this is the thickness of wall, this is the plan view of the wall. Okay, and for columns, for frames, you have to define it, but as a default, when you go to defining frame sections in ETABS, you will see this kind of a local axis arrangement. So about the major axis, generally it is axis 3 3. About the minor axis, generally it is axis 2 2. So just like the wall, you will see the axis system over here also. Now what is your specific understanding do you want over here? So this is the local axis system that is usually followed. So if you have any specific doubt, you may ask. Okay. Then next question is from engineer Dinesh. He is joining us from Tamil Nadu, and he is a working professional. His question is, I have a continuous beam with 3 spans having a beam length of 9 feet each. There is a cantilever beam of length 19 feet at the end of continuous beam. Total span of cantilever with continuous beam is 42 feet. So he is saying that his beam arrangement is something like this. This is 9 feet, then 9 feet, then 9 feet, and then straight 19 feet cantilever. Okay, this is 19, and this is 9, 9, and 9. Total span of cantilever with continuous beam is 42. I don't know how he is getting 42. 9 3 27 plus 19 should have been 46. I'm not sure why he has written 42 feet. It should have been 46 feet. Anyway, beam size is 15 inches cross 42 inches. 42 inches will be how much? 12 into 4. 12 into 4 feet. 42 inches will be how much in mm? 900, and then you have got 6, so it will be 1050, I think. Yeah, 1050 mm, and 15 inches will be how much? So it will be 375 mm. So his beam cross section is 375 by 1050. Now he's saying with reinforcement 6 numbers of 32 dia on top and bottom. We have a single piece of 32 dia bar as 39 feet length. Therefore, lapping is required. How to provide lapping for this beam? So, see, let's say this is your top reinforcement and this is your bottom reinforcement. Now, simple, you don't, if you have 39 feet, don't think that you should provide in this case, you try and having only one lap. No, I would say you can have multiple cuts in your bars. If you want to add a top splice at any top location, you can have, these are the preferred locations for your top bar splices. If you want to have any splice in the bottom bar, these are the preferred location for splices in the bottom bar. Here, 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 and anywhere over here. Anywhere in this span, you can have a bottom splice. So don't think that if it is 39 feet, the length of bar, and uh, your total length of beam is 46 feet, you are only thinking in terms of one splice only. No, I would say you may have or try having even multiple splices if required to set up your arrangement. Now, as I told you, top bar splices can be preferred in these three locations. So now you will have to work out whether this bar length is suitable for you, okay, or this bar length is suitable for you. You also have to think in terms of handling the bar. So a 32 feet bar, sorry, 32 dia bar weighs how much per kg? How much does it weigh? Around 6.32 kgs per meter. Is it correct? So handling that bar and placing that bar is also a challenge. Okay. Handling that bar and placing that bar is also a challenge. So don't think that you only need to then provide only one splice. If required, you can provide multiple splices. These are the suggested locations for splicing in the top region. And for the bottom region, these can be the suggested locations. Now you work out, and entire this cantilever portion in the entire length, you can have splices in the bottom bar anywhere in this cantilever. So accordingly, you just figure out what length you want to provide for the splice. Okay. All right. So Mr. Tamilarasan is asking, can we have lapping for backspan of cantilever? Now try not having, see, and now try for this bar. Now people say that, let's say in the first half, you will get your maximum, you will get the maximum cantilever moment, and then it will come to zero, let's say. So try not having a splice, maybe in the backspan portion. Let's say if this is half, it is 8.5 feet. Try not to have a splice in the backspan till here at least. So that means don't have a splice at this location. You may continue till this location for your bar, and you may have a splice. Let's say this is bar 1, you have a splice over here, and then this can be bar 2. Understood? So if you want to avoid lapping in the backspan, you can do it this way, something like this. Mr. Tamira is asking, is there any condition such that if I have a cantilever of 19 feet, then we should have lap it for 19 feet? No, I would say not required. See, the major moment in your cantilever is uh, the moment at the face, cantilever face. All right. and then it drastically reduces as you move away from the fixed end of your cantilever. So I would say around half. Even if you are able to provide a backspan of around half, that is, let's say it was 19 feet, 8.5 is the half. So even if you are able to provide a bar 8.5 feet straight, it's okay. And see, the basic principle of lap is that you are providing a lap so that the full development length of bar gets generated. So anyway, you will be providing the lap over the full development length requirement. Okay. So these were the questions on our Google form. Now let us take up. There was one question asked in the WhatsApp chat. Uh, Let me just see. There was one question asked on the WhatsApp chat by engineer Allah Baksh M. So he has shared this image, and he has this structure where these columns are straight, as I understood from his discussion, and then these are inclined columns, and then this is an inclined roofing. I mean pitched roofing, and this span is 31 feet. So his question is how to design the roof, and the wall here is slanted. So the columns are also slanted, 6 feet in length. Bottom floor columns are straight, top floor columns are slanted, and it is due to some architectural requirement. So, I mean, the basic, there will be no basic difference in the analysis. You may have to model it like this. Okay, you may have to model it like this, and then for this pitch roof, you calculate all the wind loads, etc. Everything. For this slanted columns, you calculate the wind loads. They may not be very different from your condition when if you had a straight column. So even for a slanted column, your wind load coefficients will be the same. So all those things. Now when you apply the loads, you just need to check because of this slant, there will be additional moments created. So those you have to take in account. Okay. So additional moment due to the slanting nature, that you have to design it for. That you have to design it for. Okay. And in these types of structures, you will have to be slightly careful about the stability also, although this will be stable because this is sort of getting balanced. But for lateral loads like wind, you may have to check its stability. So because of this shape, you can try doing some p delta or p small delta analysis also, just because of the geometry. You want to see if that geometry will destabilize. So for that, you just check for the P small delta and P capital delta effects also. This additional moment due to slanting nature will be automatically captured when you model the slant columns. Automatically, the moment effects will be captured. So no need to worry about that as much. But my understanding is that stability checks may turn out to be important for this shape. So doing a P capital delta and P small delta analysis is suggested. Okay. All right. So this was his point for discussion. Then we had a question provided by engineer Balaji. He is asking, in 13920, when the wall in 13920, when the pier wall exceeds 0.2 fck, it is required to provide boundary elements. Okay, so you must be knowing this, that if this is the plan of my wall, okay, let's say this is the length of the wall and this is the thickness. So, and let's say in elevation, if I try to draw it in elevation, so this is my height. Now, what is question is that in 13920, when the stresses in wall, so when the P by A plus M by Z in the wall exceeds zero point 0.2 FCK, then you need to provide boundary elements for a length from extreme end to distance where it reaches 0.15 FCK. No, not like this. This length is not the length in the plan view, but rather it is the height till which the stress levels reach 0.15 FCK. So that means if at this section 1, if you could have the P1 and M1 and you find out the P1 upon A plus M1 upon Z, and let's say this is more than zero point 0.2 FCK, then you provide boundary element. Then you, let's say, calculate at section 2 along the height of the wall. Let's say the axial load was P2, moment was M2 at this section. So P2 upon A plus M2 upon Z. Now if this is still greater than zero point 0.2 FCK, so at this section also you need a boundary element. At this section 3, if your stress level becomes less than 0.15 FCK, then you need not provide boundary element. So that means you will have to continue the boundary element along the height till section 3. So along the height of the wall till you reach a height where your stress levels go below 0.15 FCK, you have to continue your boundary wall. You have to continue your boundary element. Is that clear? So this is how you need to understand the boundary element requirement. Am I clear with this? Now, how do you calculate this height then? How do you calculate this dimension? So this dimension generally, just hold on, I'll be back. Yeah, is my voice audible now? So now for this dimension x, there is no direct criteria given to us in the code. 13920 does not tell us anything about it. So you may refer to some Euro code where they have given some criteria. I think they say that the minimum boundary element you should provide should be, I think, 0.15 times the length of the wall. But this 0.15 should not be confused with the 0.15 FCK. Okay. There they say that it should be uh, the boundary element length shall be around 0.15 times the length of wall. I think that is a criteria given in the Eurocode, but no direct criteria is given in the Indian standard for this length. But how do you work out this length basically? So this will be based on some trial and error procedure. Why trial and error? Because let's say you decide that this is your length of the boundary element. Okay, so at section 1 you required the boundary element because your stresses were more than zero point 0.2 FCK. So you decide that this shall be the length of boundary element. Now this becomes the center to center length of the two boundary elements. So then you can find out the tension and compression in the boundary element, which will be total moment M mu, let's say, total moment, minus the moment taken by the web. Now what will be the web portion? So this becomes your web portion. So you subtract the moment taken by the web. This has to be resisted by boundary element as tension compression couple. So you divide it by the distance between the centers. So let's say it becomes LW minus X. So in this manner you get the T and C that has to be resisted by this boundary element. And then you find out whether this particular size of the boundary element can resist that tension or compression or not. If not, then you revise these sizes of X. So in this manner, this X is slightly trial and error based. Okay, this X is slightly trial and error based. So you have to do it that way. How does ETAB calculate it? So ETABs does not. So ETABs, you should not check the boundary element length that ETABs gives you. Why? Because ETABs does not consider the moment capacity of this web portion. Moment capacity of web portion is not considered by ETABs. Okay, so ETABS uses what is called as a simplified CNT approach, where what it does, that whatever is the total moment, it will just divide it by, it will consider that this web is unable to take anything, so it will just divide it by the distance between the two boundary elements, and then find out the TNC, and to accommodate this TNC, whatever X is required, it will provide that. So don't follow the ETABS procedure for boundary limit calculation because it is unable to consider the moment capacity of this web portion. So I'm calling this as the web, and I'm calling this as my boundary element, and this as my boundary element. So in our courses on the seismic design for 1893 and 13920 and our basic course on RCC design, we have covered these issues in great detail. So there we have discussed how to do all these boundary element based calculations, but do not follow the boundary element calculation by ETABS because it does not consider the moment capacity of the web. It uses a simplified TNC approach to give you the x dimension for boundary element. So just don't use it. Okay. All right. Try to do it manually using this method that I just explained it to you. So you calculate the TNC, it will be the moment that you have to resist minus the moment capacity of the web. This moment capacity of the web can be calculated as per the appendix A of IS 13920. So there is this formula given in appendix A. So you do that calculation, then you divide it by this distance to get the TNC. Once you get that TNC, basically you can figure out, you have to design it as a short column. So then you can check the design for short column and try and place the reinforcement in it. Okay. All right. So this was his question. Then what else do we have? Okay, so then these were the questions on WhatsApp. Now let us see the questions on the YouTube live comments. So Mr. Sanjeet Kumar is asking buckling analysis किस लोड कॉम्बिनेशन पर चेक करें? I don't know. So if buckling analysis is, let's say, related more to stability check, as per our Indian code, maybe you can check for 1.2 dead plus 0.5 live, the similar load combination that you use for P delta, but I'm not sure about this answer right now. Then Mr. Padmavijayan PV is asking how to design a circular underground water tank with a volume of 15,000 liters, considering a diameter of 22 meters and height of 4 meters, including a 14-meter inner diameter circular slab with center support and 6 columns along the 14-meter perimeter. Can you explain table 21 moments in circular slab with center support fixed edge? See, in our course on liquid retaining structures, we have covered these circular tanks and we have explained in a lot of detail how to do these calculations. So probably you could have a look at that. He is saying he has a circular tank 14 meters in diameter and whatever is the height, okay, and then it is filled with liquid, whatever is the water height, and then what he is saying, considering a diameter of 22 meters, oh sorry, not 14 meters, 22 meters, 22 meters, height is 4 meters, 14-meter inner diameter circular slab. How come 14-meter, one at one place you're writing 22 meter, at one place you're writing 14 meters? I'm not sure what are the exact dimensions. He has a central column somewhere, and then he has some slab systems, maybe, I don't know, something like this. I would say if you are only having one central column, it is not appropriate. My suggestion to you would be with center support and 6 columns along the 14-meter perimeter. Maybe a sketch will be more helpful rather than just writing over here. And what you can do is that this tank portion, instead of referring to IS 3370 tables, I will suggest you that it will be more appropriate to just make a quick model in ETABS or STAD and take the moments from there. It will give you quicker moments. Quicker moments means it will give you moments more easily rather than using a table or referring a table. This will be my suggestion to you. Okay. If you could share the proper sketch, that would be more helpful. And in our course on liquid retaining structures, we have discussed all these things in great detail. All types of liquid retaining structures have been discussed. So I think I will suggest you to have a look at that course. You will understand all these things in great detail, including how to look at such tables, 3370 tables, how to model them, how to model these shapes, how to apply the liquid load, and all those things. So I'll suggest you to have a look at that course. That will greatly help you for analysis design. Similarly, for this also, overhead circular water tank. So in our course, as I'm telling you about the liquid retaining structures, we have done all these types of structures in great detail. So I'll suggest you to have a look at that. Okay. Then Mr. Magaj is asking what could be a possible reason that beams with membrane slabs show higher reinforcement. See, when we consider the membrane slabs have no uh, out of plane stiffness and they cannot resist any moment out of plane, so therefore all the loads gets transferred to the beams and therefore you see greater moments in the beams. When you consider the slab as shell, some moment gets transferred from slabs directly to your perpendicular beams, and so the moments on the main beams are slightly reduced, and that's why when you consider the slabs as membrane, you see more reinforcement as compared to a shell like behavior. But if you try and understand the actual behavior of your slab that you cast, RCC slab, that is, it is closer to a shell like behavior rather than a membrane like behavior. Now in softwares like STAD, we used to go for only load transfers as if the slab was membrane like. because the analysis engine was not that much developed. So we used to go for normal load transfer, assuming a shell like behavior of slabs, and we would not model the slabs instead and just transfer the loads on the beams. The main reason was because the floor modeling options were not so great in STAT back then, but now in ETABS, you get good options for shell modeling also. So the behavior of the slab is closer to a shell-like behavior rather than a membrane-like behavior. Okay. Mr. Arbaz Kazi is asking, what does the ACI code say about boundary element? I'm not sure. I don't know what it says about the length of boundary element. I don't know. But as I explained, the length of boundary element is more to do with a trial and error procedure. Trial and error means you try and figure out first the moment that needs to be taken by the boundary element, then you find out the TNC couple, and then you try to accommodate the reinforcement, or you want to check your boundary element size for the tension force T. Accordingly, you will have to find out the sizes. Of course, you need to add the gravity loads also to this. So how much of the gravity load component is taken? What is the TNC? Depending on all that, you need to figure out and find out your sizes. Okay. Mr. Swaroop VP is asking, for low-rise buildings, should we add section modifiers to shear walls during seismic analysis? See, if you are doing it as per IS 456-2000, as of now, there is no requirement of modifiers. No modifiers are given. Of course, the ACI 318 tells you about the modifiers. The IS 16700 also tells you about the modifiers. So, I mean, behavior wise, yes, modifiers should be included. But if you want to strictly follow the code, they don't talk about modifiers. So I have no comments right now whether you should add modifiers to shear walls uh, or not. I have no comments right now. Only for seismic analysis, if you just want to check the drifts, you can add modifiers because IS 1893 tells you to do so. So only for seismic analysis where you have to check drifts, you can add modifiers. Yes, that can be done, but not for design. Mr. Akash Wankede is asking, if we cut the column size by 3 inch per floor, will it affect the structure? Yes, the stiffness of column will change. The column stiffness will change. So you will have to consider the effect of changing stiffness. Let's say in elevation, I'm trying to draw this. Of course, this is quite an exaggerated diagram. So he's saying at this, his column size is this, then he cuts down by 3 inches, and he further cuts it down by 3 inches. So will it affect the structure? So of course the stiffness gets affected. So analysis will get affected by it. Okay. Yeah. So if you are going to make changes in the sizes, you should uh, model those changes or model those changes in your main model also. You should make those size change in your main model also, and then your model will consider the changes in analysis based on those stiffness. So engineer Padma Vijayan has shared these images with me. This was his query related to that water tank that he had put. So this is his condition. Okay. So queries he has already asked. My suggestion will remain the same, that you model this entire thing. It will be better if you model this, or you can do it in two parts. The tank portion you can model separately. Okay. Tank portion you model separately. You find out the wall thicknesses separately. Consider them to be pinned at top and fixed at base, and model it separately. And then this portion you can model separately, where you model this column Okay, you model this wall also maybe, and this central column. Model the top slab over there, apply the load on the top slab. From there you will get the axial forces in columns and the moment in these beams. From there you can find out the column drop requirement for this column. So this you can do in a separate model maybe. Okay, and then you can take this model for raft analysis design also. So I'll suggest you to do this thing in two parts. First, you just make a wall model, because the effect of the slab load, it's not going to affect your wall reinforcement as such. So therefore, I'm suggesting you first make only a wall model, apply the water pressures, and find out the wall reinforcement requirements. Do all the IS 3370 checks over there. There are a lot of checks that you need to do. And then in a second model, where you just want to design your top slab, you model the wall, you model all the columns, apply the load on top slab, and then see what is the requirement for column, beams, etc. And then take that model to your raft and then do the raft also over there. Okay. All right. Okay. Mr. Tamilarasan is asking, as per IS 13920 for column, minimum dimension shall not be less than 20 times, or this, if my vertical member size is 230 cross 1000, it will be shear wall. Yes. So that is a uh, lag as of now in the 13920, where you can take advantage of that lag. Lag means there is this gap that is there, that if you start taking your d by b greater than 4, then it gets classified as a shear wall or RCC structural wall, and then you may not need to follow all these column related requirements, and then you can straight away jump to the shear wall requirements. Even then the checks for beam column capacity ratio or joint shear checks are also not required. So as of now, that is a gap that is there in the code, and people try to exploit this gap by taking the d by b ratio more than 4 and then designing it as walls. Yeah, people do that. Mr. Swaroop BP is asking, what is the reason to provide 20 times the diameter as minimum dimension in column? Because to avoid the bar slippage over the column seat. The reason for providing this 20 die requirement is, if in elevation I show you, this is my column width and this is my beam. So you will have your bar in the beam, reinforcement bar in the beam. Okay. So if this, what the research they have found out, uh, due to cyclic loading, what may happen, that if your reinforcement bar does not get adequate seat on this column, then under the cyclic loading, it is unable to perform in an expected manner. Okay, especially at the end location. Sorry, I should have drawn it like this. At the end locations, this criteria becomes more important, that this column is going to end, beam is going to end. Now if your reinforcement does not get that adequate seating, then it is not able to perform as per expectation under the effect of cyclic loading. So that's why your code has come up with this requirement of minimum seating to be 20 times this bar dia. Okay. Okay, so I think we have taken all the queries. Mr. Tamilarajan is asking, for shear walls, is it necessary to have minimum dimension of 20 times bar dia? So see, as I told you, if you take the d by b more than 4, it becomes a shear wall. Now for shear wall, no such criteria is given. Now technically it should still have that 20 dB criteria, but then that 20 dB criteria is given only in the column section, not for walls. So it's a gap right now that the code has, and engineers exploit that gap by providing a d by b more than 4, and then they are not required to follow any of this provision. Okay. Yeah. So in the upcoming revision of 13920, you will see these changes, that even for walls, they will require these criteria to be satisfied: the 20 dB times criteria, or the uh, moment capacity ratio criteria, or joint shear criteria. All those requirements will have to be satisfied for walls also. Mr. Akash Wankhede is asking, is there any option to define one-way, two-way slab in ETABS? See, whenever you model any shell element in ETABS, as a default, it is not one way, two way. It will distribute load on the basis of its stiffness. So there is no direct option to define one way, two way. It will transfer the loads based on the stiffness behavior and the aspect ratio and support conditions. Now you can, if you want a strictly one way behavior, there is an option to define your shell element as a deck, or you can give some modifiers, M11, M22 modifiers you can give. So suppose you wanted your slab to behave only in this direction, and let's say your local axis is this, then you may give a M11 modifier close to 0. Then what will happen? Your behavior will be like a one-way behavior. But as a default, when you model any slab in ETABS, it's not one-way, two-way. The behavior will depend on the stiffness and the aspect ratio and the stiffness of the supporting beam column. So in the sessions, we have discussed these things in detail. You go on watching the sessions, you will understand what I'm saying. Okay. Mr. Swaroop PP is asking, does your course for liquid retaining structures include seismic analysis? Yes, it does. We have done detailed calculations as per IS 13920 part 2 for liquid retaining structures, and we have done the detailed calculations for the hydrodynamic loads. Okay. Yes, the convective loads and the, what was the other type? There is one convective, and I forgot there's one more type of load. For all those types of loads, we have done detailed calculations. Yes. So I think that is all for this session then. We have taken up all the questions. How to connect a lintel beam, Mr. There is one question from Engineer Chandrakant. He is a working professional from Srinagar, and he is asking, how to connect a lintel beam with main column. See, if you are in a high seismic zone, do not connect a lintel beam with the main column. Okay, so you just keep your lintel beam only for your wall support, opening support in your load bearing in your masonry walls. Only for that you give that lintel beam. So I will suggest you not to connect your reinforcement, lintel beam reinforcement, with the main column. Don't do that. And even if you want to do that, just provide some minimum reinforcement. Don't take it to development length also. And I mean, just maybe just do it like this. Don't develop it. No need to develop your reinforcements. So do not connect the lintel beams with columns. No. If you are providing cut lintels, that will be even better, that only above the openings you provide a cut lintel, something like this. Okay. If you are deciding to include your lintel beams and then you want to develop the reinforcement also, then it is better that you include the lintel beams in your model and consider them to be part of your framing system. Then you do it that way. Otherwise, do not connect your lintel beam with the main columns. His second question is, what is the LD value in detailing for secondary beam connection to the primary beams? We in secondary beam to primary beam connection, if we only want to develop a shear connection, because generally beam to beam connection we don't want moments to be developed, because then it generates the torsion in the primary beam. So let's say this blue is my primary beam, this purple is my secondary beam. So ideally we do not want the reinforcement to be developed inside. So maybe around LD by 3 and you just leave it as it is. And for shear transfers, we do provide this kind of a detail where, let's say, this is the elevational view and this is my secondary beam. We do like to provide this kind of a detail in my primary beam, this hanger like reinforcement, which will take care of the shear transfers. Okay. So if you wanted to provide any value, maybe LD by 3 or LD by 4, or just provide 100 mm, 200 mm, that's it. Okay. Yes. So I think that's it for this session then. We have answered all the queries in the Google form. We have answered all the queries in the YouTube comments, and we have answered the queries from the WhatsApp chat also. So this is all we have for this session. Now next session when we conduct, we will continue with the questions. In the meantime, if you have any questions, the same Google form link, you can put your questions. I'm just putting that link over here. So in this link, you can continue putting your queries, questions throughout the week. And once every week when we meet, we take up your queries and questions. And if you want to contact us on WhatsApp, uh, I'll just put a link for that also. Yeah, so I have put a link if you want to contact us on WhatsApp directly. This is that link. So you can click that link to connect with us on WhatsApp. So this is all what we have for this session. Thank you. And now we will meet you next weekend. So that's all. Thank you and bye bye.